Hello everyone, welcome to Scalar's YouTube channel. My name is Sumit Shukla, a senior data scientist and an educator. In this particular video, we will talk about the maths behind linear regression. But before we start this video, don't forget to check out Scalar's free masterclass by leading industry experts. The link is in the description box. So let's get started. So in the last video, we have talked about various components of machine learning. What is supervised learning, what is unsupervised learning, what is regression, what is classification. Now in this particular video, we will start one particular topic which is regression. And this is going to be a detailed video about regression. We will spend a lot of time understanding the maths behind regression. Then we will also understand how to evaluate a machine learning model, a regression machine learning model, followed by a Python demonstration where we will try to understand how we can solve a business problem by writing some few lines of Python code. So that is what we are going to do in this particular video. Let's get started. Now the very first thing is, what is linear regression? Now before we jump into the detailed discussion around linear regression, first of all, let's quickly write down few important pointers. Number one, this machine learning algorithm falls under the category of supervised machine learning. This is very first thing. Second one is, this particular machine learning algorithm falls under the category of regression. That basically means the data. So let's say this is my data. We have TV marketing budget. Then we have radio marketing budget. And then we have the corresponding sales. So if this is my kind of data that we have, then this is my target variable. And why this is my target variable? Because we want to predict. We are interested in finding out what is going to be the corresponding sales if my TV marketing budget is X units and radio marketing budget is, let's say, Y unit. So let's call this as X1, let's call this as X2, and let's call this as Y. So I want to predict, so I'm interested in predicting the corresponding sale, the sales corresponding to X1 units of TV budget and X2 units of radio budget. So for example, let's say if I'm going to invest some 20 lakh rupees in TV marketing and my budget for TV marketing is 20 lakh, and let's say for radio marketing I'm going to invest some 3 lakh rupees for radio marketing. Then if this is the kind of input that we have, then what is going to be my corresponding sales? What is my output? That is what we are interested in finding out. Now, this is what we can solve using linear regression. So I hope you guys would have understood the background about when to use linear regression. But the major question is, what is the maths behind regression? What is the core maths behind linear regression? So let's start with a very fundamental topic or very fundamental idea. Let's talk about a problem. Now let's say you are interested in buying a house. So you want to purchase one particular house. Now, can you guys tell me what are the various components or what are the various features on which the price of the house is dependent. So in what all features are there on which the price of the house is dependent? What it mean? Let's try to understand this. So if you are interested in purchasing a particular house, we know that if the house has a higher area, so very first component is area. If the area of the house is high, we know that price is going to be high. The second component is number of rooms, or maybe number of rooms, kitchen and bathroom. So BHK, number of BHK. Then the third one might be whether it is furnished or unfurnished. Furnished or unfurnished. Then another component would be whether the house is in a very prominent or a posh area or not. So let's say the tier city or maybe the tier of area. So I would write this as, let's say, the class, area class. Area class. Maybe one more feature can be, what is the age of the house? Age of the house. Now let's limit ourselves with only these many features, but we all can understand one thing. All these features are going to somehow influence the final price of the house, right? Final price of the house. So if the area is high, so let's write down all the relationship. Number one is, if the area is high, price is going to be high. If the number of BHK is high, then again price is going to be high. If it is furnished, so furnished is equal to yes, then again price is going to be high. And if the class, the area class is going to be, let's say, 1, first class, then price is going to be high. If the age of the house is high, let's say the house is a 50 years old house, so age of the house is high, then price is going to be low, right? Because if there is a house which is a new build house, then the market value of that house would be high, otherwise it would be low, right? So this is a kind of relationship that these inputs will follow with this output, or this output will follow with these inputs. Now, can I write down this complete logic in a mathematical equation? So can I say my price of the house is somewhat dependent on area plus somewhat dependent on number of house or number of BHK plus somewhat dependent on furnished or furnishing status plus somewhat dependent on the area class plus somewhat dependent on the age of the house. Now this is something which is known as a mathematical equation. So I'm saying that the price of the house is somewhat dependent on area. Let's say this particular term we are going to call it as beta 1. Let's call this as beta 2. Let's call this as beta 3. Let's call this as beta 4. Let's call this as beta 5. Now what is the meaning of this? This basically means that if the area of the house is high, then price is also going to be high. And how much it is going to be high? By that factor of beta 1. So if I increase the area of the house by some units, price will also be influenced by beta 1 units. Now this particular term, which is also known as a coefficient, will influence the price. So how much my price is dependent on area? This much, beta 1. How much price is dependent on number of BHK? This much. how much my price is dependent on furnished, this much. Let's give beta 1, beta 2, beta 3 a random value so we can understand it in a better way. Let's call this equation to be price is equal to 7 times of area plus 2 times of number of BHK plus 3 times of furnishing status plus 2 times of area class, and plus 9 times of age of house. Now, what is the meaning of this? If you carefully observe, price is highly dependent on age. It is 9 times. So that basically means if the age of the house is 0, or maybe the age of the house cannot be 0. Let's say age of the house is 1 month, which is 0.1. Then price will be very high. Similarly, if the house is, let's say, has a higher area, so if the area is high, then again price is going to be high because there is a contribution of 7 units. So 7 times of area will contribute towards the price. If the number of BHKs are high, price will also be high. If the furnishing status is furnished, yes, then again the price of the higher house will be again high. So all these factors, all these features are contributing towards the final price. These features, which is all these one, are known as your independent features. Independent features. And why they are known as independent? Because they are not dependent on someone. While the price, this is known as the dependent feature. Because this feature is dependent on all these independent features. So in order to calculate the price of the house, we need to figure out the area of the house, the number of BHK, the furnishing status, the area class, the age of the house. When we have all these inputs, I can find out the price. And since my price is dependent on all these features, we call these features to be independent and this feature to be dependent. Now, I hope you guys would be able to understand that this equation resembles some kind of equation that you guys would have already seen in your high school maths, right? So this equation replicates to an equation of a straight line, which is of a form y is equal to mx plus c. We will talk more about it, but let's now understand what is the point of creating this model, or what is the point of doing all this. So let's say I have this kind of data. I have a data of the area of the house. Let's say I have the number of BHKs. Then we have the age of the house. Then we have the furnishing status. Then we have, let's say, the age of the house is done. Let's say class, the class of the house. And finally, the price of the house. Now, this is my historical data. This is a data that has been gathered, let's say, by some website. Let's take example of housing.com. So let's say housing.com, they have collected this data after doing a wide range survey, and they have picked up various houses with their various features like area, number of BHK, age of the house, furnishing status, class of the house, class of the area, and then the price of the house. Let's say we have the data of, let's say, 1 lakh houses. 1 lakh houses. Now, let's say housing.com want to come up with a application on their website, a particular web application where you can estimate the price of your house. So let's say I want to sell my house and I want to estimate how much price I can get if I put my house on rent or maybe on sale. So what is my estimated price or the value of the house that the owner may expect. Now, in order to generate this kind of web application, which can predict, which can compute the price of the house given various inputs. So what the user has to provide, so let's say this is the owner, and this owner is willing to sell his house, Now this owner will be required to put various inputs in this website. So let's say this owner has to provide what is the area of the house. Let's say the area is 110, let's say 1100 square feet. Then we have BHK. Let's say BHK is 3 BHK. Age of the house is, let's say, 5 years. Whether furnished. So furnishing status is yes. Area class is, let's say, it is first class. Then when the owner provides this input to this web application should be capable of generating the estimated price. And how this can be done? This can be only done when I enable this web application with a predictive model. How we can generate this predictive model? So I will provide this data to my linear regression algorithm, and the algorithm will compute the mathematical expression. And how this mathematical expression will look like? So we have to go back and look at this equation. This is the equation that we have generated logically, right? We haven't utilized any kind of heavy math topic. It is a very logical expression where I am saying that the area of the house is going to influence the price. So my price is dependent on area. Price is dependent on number of BHK. Price is dependent on furnishing status. Price is dependent on area of the class or class area, and price is dependent on the age of the house. So all these independent variables are influencing the price, and this is a kind of mathematical equation that I would end up getting if I provide this data to my linear regression algorithm. So let's say I obtained this equation, where my equation is price is equal to beta naught plus beta 1 times of area plus beta 2 times of BHK plus beta 3 times of age plus beta 4 times of furnished plus beta 5 times of class. But as of now, you guys can see one thing, that I do not know the value of beta naught, beta 1, beta 2, beta 3, beta 4, beta 5. How we can figure it out? This is a task of the linear regression algorithm. So my algorithm will utilize this historical data, to figure out these parameters. So my beta naught, beta 1, beta 2, beta 3, beta 4, beta 5, all of them are known as your parameters. And they also have one name known as coefficients. They are known as coefficients. Now this is the task of the algorithm to learn these coefficients utilizing the data. The task of the algorithm is to learn or estimate these coefficients using data. Now once this is done, once I have this equation ready with me, now I can provide this equation. I can put this equation in this web application. So I can put this equation with the values of beta naught, beta 1, beta 2, beta 3, beta 4, beta 5. I can provide this equation. I can put this equation in this particular web application. And then if a particular user comes and try to utilize this particular web application to estimate the price of the house, they can simply provide these inputs, and this particular web application utilizing this particular a mathematical expression can estimate the price of the house. So in nutshell, if we think about what linear regression is helping us with, in nutshell, using the algorithm linear regression, I want to find out, or the linear regression algorithm will estimate the coefficients, or it will help us with the mathematical expression, and how that expression looks like of the form y is equal to beta naught plus beta 1 x1 and so on. Now once this mathematical expression is ready, I can utilize this expression with the new input to get the output. So in nutshell, we use linear regression algorithm to find out these coefficients, which is computed by this algorithm based on the historical data. That is all what we do. And very important thing, I have already told you that this equation is very similar to something that you guys have already learned in your 10th class, which is this equation is also known as the equation of a straight line. So now let's understand a little bit more complicated maths behind linear regression. For understanding the maths, we will take this simple example. Now, this example that I'm going to take is also known as simple linear regression. Simple linear regression. And the difference between simple and multiple is nothing but the number of independent variables. So when we talk about multiple linear regression, this is the discussion that we have done around multiple linear regression. So this particular discussion that we did was the part of multiple linear regression. So the reason we are calling this particular regression technique to be multiple linear regression is because of the number of independent features. So here, my target variable price is dependent on multiple independent features, which is area, BHK, age, furnished, class. Now, since the number of independent variables are more than one, this is known as multiple linear regression. So in simple linear regression, the expression looks like this: y is equal to beta naught plus beta 1 of x. Now here, the point to be noticed is we have a dependent variable and we have one independent variable. So we have one independent variable and a dependent variable, and we are trying to figure out the relationship between them. So if you look at this particular data, here you can see that we have the marketing budget. Now this is the total marketing budget. Total marketing budget. And this is my actual sale. So this is my target variable y and this is my x. Now in this particular case, the equation that I am trying to figure out is actual sales is equal to beta naught plus beta 1 of the marketing budget. Now when I provide this data to the linear regression algorithm, it will basically try to estimate the coefficients. So essentially, we will get beta naught and beta 1. Now once we have beta naught and beta 1, we can basically create the model or basically the expression. And once we have the expression, we can make predictions out of it. So if I have a particular marketing budget, let's say now the marketing budget is, let's say, 132 lakh. Then if I provide this value to this expression, then this expression can help us with the estimated sales. Now this is what is going to happen. But the major question is how linear regression is going to estimate these coefficients, beta naught and beta 1. Let's try to understand this. Here, look into this particular image. This scatter plot is basically the same scatter plot which I have derived or which I have plotted using this data. So here you can see that on the x-axis we have the marketing budget, on the y-axis we have the sales, and here you can see that we can find out various data points. So for example, for this is around 250,000 corresponding to this. What is the sale? So it is around 10 million. So when we invest $250,000, we can get a sale around $10 million. This is the relationship, right? Now we are trying to find out a line, and this line, I hope you guys are able to see, this is the line. This line is also known as a trend line. And this line is given as y is equal to beta naught plus beta 1 of x. So right now my y is sales is equal to beta naught plus beta 1 of marketing budget. This is basically the line. But how to find out this line? How to find out a line given a data? And please remember one thing, a line is something which we define using the set of coefficients. So if I draw this line, then this line will have different set of coefficients. So this will have, let's say, beta naught dash, comma, beta 1 dash. If I draw this line will have different set of coefficients, let's say beta naught double dash and beta 1 double dash. So each of the line we draw, it will have a different set of coefficients. Now using that, I can generate that line. So the point is that out of all these line, here you can see I have just created a very dummy example. You can see that this is line 1, line 2, line 3. So out of all these line, which line is the best line? Because this is the objective, right? Among all these lines that can pass through the data, I want to pick that line which is the best line. That particular line will contribute towards the mathematical expression which the linear regression algorithm is trying to estimate. But how to find out this line? Now think about this logically. If I go with this line, the line which is represented in green, you can see that the green line is not passing through most of the data, right? While the one in the red is passing through most of the data, and while the one in blue is very far away from the data. So I want to find out that particular line, or I will select that line among all these lines which is around most of the data points. Now let me give you one example. Let's say this is my data. This is X, this is Y, and my data is, let's say, this is my data. Now here if I ask you what is the best fit line, you guys can easily say that this is going to be the best fit line. Why? Because this line is passing through most of the data point, and this line is very close to most of the data point. So very close to most of the data points. Now this is one of the idea, but this is not the only idea. Please remember this. This is the one of the idea to fetch or to find out the best fit line. So one of the idea is that I will choose or pick up that line which is close to most of the data point, or which is passing through most of the data point. But this is not the complete idea. Now, if I ask you, what is the prediction? So let's understand one more point before we can jump to the next topic. Let's say this is my data x, y, and this is, let's say, 2, this is 4, this is 6. Let's say this is 2, this is 4, this is 6. And let's say we have some data points. Let's say I have a data point over here. I have a data point over here. I have a data point over here. And then over here. Now let's say this is my best fit line. Now let's try to understand what is going to be the actual and what is going to be the predicted value. So for x is equal to 2, this is x is equal to 2 over here. The prediction is going to be on the line, which is this point, which corresponds to 2. But the actual is over here, which is the red color point, which is going to be 4. So let's write down y actual. Y actual is going to be 4, and y pred according to the line is going to be 2. Now you can get the same answer 2 using the equation y is equal to beta naught plus beta 1 of x. So as of now, we do not know the value of beta naught and beta 1, but let's say if I know it, I can simply put the value of x is equal to 2 over here, and I will get the output as 2 only, because the point that I am going to predict at a certain value of x is going to lie on the line itself. Now when my x is 4, so when my x is 4, my prediction is 2. Sorry, my actual is 2, because red color becomes 2. So actual is 2, but my prediction is 4. When my x is 6, then my actual is 4. So actual is 4, but prediction is 6. Now you can see this is how we try to find out the actual and prediction. Predictions are always going to be on the line, while actual is represented by red color. Now one of the idea to find out the best line is to look for that particular line which is close to most of the data, while the correct logic is to find out or pick that particular line for which this difference is minimum, because I want to find out that line which can predict values which are close to the reality, which are close to the actual value. So the point is, we will choose that line as best line for which the difference between actual and predicted is minimum. So this difference between y actual and y pred, this difference is known as the residual, or you can simply call this as error. So this difference should be minimum for a particular line, and I will choose that particular line. Now you guys have got a basic idea, right? That in order to find out the best line, the idea is to look for that line which is close to most of the data point, more logically, more mathematically, the idea is to pick that particular line, for which this difference, the difference between y actual and y predicted, is as minimum as possible, because my objective is to get that particular line which can predict values which are close to the actual values, predict values which are close to the reality. This is the logic, right? Now, let's do one simple exercise to understand how we can convert this residual in a form of a equation which can help us to find out the best fit line. If you are not able to understand this logic, don't worry. Let me do some exercise so that I can help you explain the logic. Let's look into this diagram. Let's assume that this is my best fit line given as y is equal to beta naught plus beta 1x. All these blue data points are my actual data points. So this is my y actual, and this line is my y predicted line, right? So when this is my x, this is y actual, this is y pred. So when x is 1, my actual value is 3, but prediction is around 3.5, right? When my x is 2, my actual is 7, right? But prediction is going to be around here, which is 4. When my x is 4, my prediction is 6. But actually it is 6, prediction is going to be 5. When my x is 6, my actual is 4 over this point, but prediction is 6. And when my x is 8, then the actual value is 8, prediction is 7. Now let's calculate error. So error is given as y actual minus y predicted. So 3 minus 3.5 minus 0.5, 7 minus 4, 3, 6 minus 5, 1, 4 minus 6 minus 2, 8 minus 7, 1. Now, let's say I want to find out total error. Why? Because for each of this line, I will fetch out the total error made by this line. So, what is the total error made by L1? What is the total error made by L2? What is the total error made by L3? And then among all these lines, I will pick that particular line for which the total error is minimum, right? But there is a problem. If I simply compute the summation, there is a problem. You can see that the positive values will cancel out negative. So this minus 2 will cancel out plus 3. This minus 0.5 will cancel out plus 1. So you will get a value which is not correct, which is going to be misleading. So there are two options. Either I should take absolute of E, absolute of error, or I should square the errors. Now there is a reason, there is a mathematical reason why I am going to go with this option. We are going to utilize the square of the error concept, not the absolute of the error. The reason is that square of the error is a differentiable function. Now this particular topic is beyond the scope of our discussion right now, but the point is that the reason we choose square as a method to make these errors from negative to positive is because the square function is differentiable in nature, while the absolute function is non-differentiable at a particular point, which is x is equal to 0. So the discussion around y square, why not absolute, is beyond the scope of our discussion, and let's not discuss it more. But I hope you guys would have got one answer, which is due to the reason behind the differentiability of this function. A square is differentiable at all the points, while absolute function is not differentiable at x is equal to 0. And I will help you explain this reason more when I go about explaining the concept of gradient descent. But as of now, let's use the square function to find out the total error. So e square. Now this is going to be 0.25. This is going to be 9, 1, 4, 1. And now we can total it. So 9, 10, 15, 15.25. This value is known as RSS, which is known as residual sum of squares. Residual sum of squares. Why residual sum of square? Because this component ya minus yp, which is y actual minus y predictor, is known as residual. Now since we are taking the sum of their squares, it is known as RSS, residual sum of square. Now if I mathematically define RSS, it is given as summation of I is equal to 1 to n, where n is the total number of data points, yi minus yp to the whole square. Now we also know that yp is given as beta naught plus beta 1x, right? So in order to predict the value of, in order to predict any value at a given value of x, so let's say I want to predict what is going to be the output at x is equal to 4. I can simply impute that value over here. Given if the value of beta naught and beta 1 are already estimated, then I will be able to figure out the value of yp, which is going to be 6 in our case. So I can rewrite my RSS as summation of I is equal to 1 to n yi minus beta naught plus beta 1 of x to the whole square. And this equation is known as RSS. Now let's go back to the previous slide. And here let's talk about the same idea, how to choose the best fit line. Now instead of using total error, I will use RSS, because RSS is the squared sum of error. So for line number 1, I will calculate RSS. Let's say the RSS came out to be 500. I'm just taking one hypothetical value. Let's take the RSS for L2 being 200. Let's say the RSS for L3 being, let's say 400. Now among all these lines, we will pick that line as our best fit line for which the RSS is minimum. So this particular concept is known as OLS, which stands for ordinary least squares method, where the idea is that we will choose that line. So among all these lines, I will choose that particular line for which the RSS is minimum. Now please remember one more thing. RSS is dependent on, or the equation of the line is dependent on coefficient beta naught and beta 1, right? So I can rewrite this OLS concept as we will choose that set of coefficients for which the RSS is minimum. And this is basically the whole concept about how regression will find out the best coefficients. Once the linear regression algorithm is able to find out the best coefficients, once we have these coefficients, once we have this beta naught, beta 1, beta 2, beta 3, beta 4, beta 5, we are ready with our equation, we are ready with our mathematical expression, and now I can use this mathematical expression to make predictions. How I will find out these coefficients? Using the concept of OLS. But there is again one problem. Now the problem is, let's try to understand why this is a very hectic task. Let's say this is my data. Let's say this is X, this is Y, and we have some data points over here. So one data point over here, here. Let's say this is my data. Now, I can have infinite number of lines passing through this data, right? So one line is this, another 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 line is this, and so on, right? So if you go about using the hit and trial approach, let's say we started with a particular line. So let's say we started our iteration, we started checking out the RSS value for this line, and this line is given as, let's say, beta naught is equal to 2 and beta 1 is equal to 2. Then we will compute RSS. Then we will have beta naught is equal to 2 and beta 1 is equal to 1, and we will compute RSS. Like this, can you figure out how many combinations would be there? So let's think about, let's say my beta naught can take only values between let's say minus 10 to plus 10. Beta 1 can take values between minus 10 to plus 10. Now, how many values are there in between this? There are 21 values over here. There are 21 values over here. So 21 into 21, these many combinations. This is the number of combinations I need to compute the RSS for. So for each of the combination, I will compute the RSS. Then I will create a table where I have all the RSS values, and then I will pick that particular combination which is going to be the minimum. Now this is known as a brute force approach, where you are doing the same kind of, like, where you are doing the solution by taking a simplest possible approach. This is something which we don't do. We are not going to take the brute force approach, the simplest form of this approach. Instead, what we use is known as gradient descent. Now, we will not go into the depth of gradient descent, but let me tell you a basic idea, the differencing and the requirement of this. If I go back, you guys know now that I need to choose the best fit line. And I cannot do this manually because it will take so many iterations. We have to do a lot of computation and it will be really expensive. In order to avoid this, we use the concept of gradient descent, where the logic is that, first of all, gradient descent is an optimization algorithm. It is an optimization method where this technique can help us to optimize a function. So for example, let's say I have a function f of x is equal to x square. Now we know that x square is a parabola and it will look like this. Now gradient descent can help us to find out the value of x where f of x, which is the output, is minimum. So at what value of x the output f of x is minimum. And if you look at the picture, if you look at the plot, you can say that at x is equal to 0, my function, the output, is also minimum. Similarly, if I talk about regression, in the case of regression, my function is given as w1 comma w0 is equal to summation of I is equal to 1 to n yi minus beta naught, or let me correct this one. So it will be beta naught and beta 1. So beta 1, beta naught So beta naught plus beta 1 of x to the whole square. So using gradient descent, using the concept of gradient descent, I can find out at what value of beta naught and beta 1 the function is minimum. Now this is something which I can achieve using the concept of gradient descent. We will not go into the depth of gradient descent because gradient descent is again a very complicated mathematical topic to understand. We have to learn about constraint optimization, unconstrained optimization and lot of things, differential calculus and lot of things. So we will not go into the depth of maths, but I hope you guys are able to understand the requirement of gradient descent. The requirement is that I want to find out the best combination of beta naught and beta vector, or beta naught and beta. Now, if I go with the brute force approach, which basically means trying out all the possible combination, it will take us a lot of time, a lot of iterations, a lot of computation power. It will be really expensive. What is the solution? The solution is we will use gradient descent approach, which is an optimization method in maths, in mathematics, where gradient descent can optimize a function. So if let's say the function is f of x is equal to x square, then using the power or using the concept of gradient descent, I can find out at what input, at what value of x, this output f of x is minimum. Similarly, here I have the same kind of requirement. At what value of beta 1 and beta naught, at what input, this function is minimum. So this is also known as the cost function or the loss function. Loss function or the cost function. And I want to find out the best value of beta naught and beta 1 using the optimization technique, which is gradient descent. This is how we can find out the best fit line. Now, once we have the best line, we are basically done. So now we have the line, which basically mean we have these value of beta naught, beta 1, beta 2, beta 3, beta 4, beta 5. Once we have these coefficients, we have this equation. Once we have this equation, we can use this equation for making prediction on new set of data. This is how linear regression tries to solve our problem. But this is not the end. We have to also understand whether this equation is actually good or bad, because this is something which we have estimated from the data. Now, there are chances that it might be wrong. So we need to learn about the methods which can help us to understand whether this equation is doing a good job or a bad job. We will talk about this. So let's move into the next video. So that was all about this particular video. I hope you guys enjoyed, had a wonderful time listening to me. Now, if you have any questions related to this video, please post your question in the comment section. I would be very much happy to answer all your queries. Before we end this video, don't forget to give this video a big thumbs up, share this video with your friends, and don't forget to subscribe to our Scalers YouTube channel.